Okay, so let's get started. So welcome everyone to Castillo-Rosales Senior Design Expo. So this year we're holding it online, so it's a virtual expo. And first I want to introduce all the participants. The project first. So this project is Pineapple Chatbots. So our sponsor is Castillo-Rosales ITS department. So we're making a chatbot for the university. And our liaison is Ki Chan. And we have 5 members from CS senior students who are Enrique and Jose, Julio, Kuong, and Eileen. And I'm the faculty advisor. And we also have some other faculty joining this presentation. So there are Dr. Raj Pamula, Dr. Huiping Guo, and we also have the ECST IT team members, Fernando, and also Ian joining us. So welcome everyone. And then let's play the welcome message from our Dean, Dr. Emily Allen first, and then we'll start the presentation. So this is the first year we make this expo online, so hope everything goes well.
Okay, so let's start with the message from our dean first.
Yeah, we cannot hear it.
Oh, I need to share my audio too then.
Yeah, I think you, yeah.
When you share it, share the audio. Go to the share and then there's a share audio. On your share screen, there's an audio button at the bottom.
Okay.
Virtual Capstone Expo.
Yes.
2020. That's the expo that's virtual, not the capstone projects. In fact, our student teams have been working on their projects since our kickoff in August 2019. That seems like a long time ago now, as the COVID-19 pandemic has forced us into physically distant but socially cohesive modes of operation. We have over 100 project presentations to share live with you over Zoom connections. We are very proud of our excellent senior design program, as it rivals programs nationwide in meeting curricular requirements for design. Engineering design is an iterative, creative, problem-solving process in which science, mathematics, and engineering and computing principles are applied to convert resources into solutions. It has a direct and vital impact on the quality of life for all people. With these stakes in mind, our students have been working hard all year long, and especially these past few months, to finish their projects, and these presentations represent the culminating efforts for their degree programs. We deeply appreciate our project sponsors and industry liaisons, our faculty advisors, and the teams that manage and provide instruction for these capstone courses, including Mike Thorburn and Chris Bachman, John Shamma, Howard Lum, Jason Song, and Rupa Purasengi, Paul Liu, Elaine Kang, Jungshu Lim, and Raj Pamula, as well as our staff members, Hasmeek Simon and Evelyn Lee. Now, on with the shows, and I'll see you online.
Okay, and now a message from Michael Thornburg.
Hi, everybody. I'm Mike Thorburn, and on behalf of the Cal State University, Los Angeles, and the College of Engineering, Computer Science, and Technology, I want to welcome you to the 2020 Engineering, Computer Science, and Technology Capstone Senior Design Expo. This year, it's a truly unique experience for us and for you, as the expo will be done live via Zoom. Additionally, Sessions will be recorded for those not able to participate in the live event. The students have all worked especially hard to make this event happen and to ensure the audience is able to participate from a safe social distance. Between mechanical engineering, electrical engineering, computer science, civil engineering, and technology, we have about 100 presentations scheduled over a period of about 2 weeks. I encourage you to participate constructively in as many as you can. Your feedback is critically important to the students. As you're watching this video, you must already know about our webpage. If you take time to go through it, you will find detail about all of the presentations and projects. Cal State LA is protecting the event from mischief by using passwords, but if you request access, we'll happily send it to you. The students have been working on their project since August of 2019. Obviously, the COVID-19 epidemic was a huge disruption over the last month and a half, and it's been hard for everybody. I'm proud to say our Cal State LA engineering, computer science, and technology students, just as they have always done, have shown great persistence to overcome the obstacles confronting them and have made a tremendous effort to wrap up their projects and present them to you now. On behalf of the university and on behalf of these terrific students, I welcome you to Expo 2020.
Okay, that was a message from Michael Thornburg. And now our presentation. Kuong?
Hello, we are the Pineapple Chatbot team, and my name is Kuong Thong. Here we have Ruan, Julio Aguilar, Enrique Castillo, and Lopez. Our academic advisor is Dr. Zilong, and our liaison is Ki Cheng. All right, to the next slide. Okay, so let's get on with what the Pineapple Chatbot is. This chatbot was created as a tool for the students to use on the university website. It should be able to answer questions related to the university. For example, we can ask for the professor's email, and the chatbot will give the user an answer containing the professor's email that was listed on the Cal State LA website. When searching for things such as forms and other information that requires a download, the chatbot should also give the user a link to where the forms are located. So if you need to find a FAFSA form to download, it would give you that link. Next slide. So how does the chatbot work? It's actually quite simple. There are not many steps needed for the chatbot to find an answer. First, the user must give the chatbot a question in English, as our chatbot is currently only trained with English data. The chatbot will try to interpret the question to its best ability. So using machine learning, it extracts relevant information from the question. These are the keywords, and they will be the entities. And what the user is trying to ask is something like what and who. This would be the intent of the question. This information is passed on to the next step, where we also use machine learning to find the best matching answer within our database, where we search through all of the websites and collected important information for each website. The chatbot then will give the answer back, the best matching answer. Next slide. This is the content we're going to talk about in this presentation. Yilin will be talking about updates on how we gather data for the database and the new database's performance. Julio will be talking about Spacey. What is it, how it works, and what are the intents and entities of a question. Enrique will be talking about what is our new classifier model and how it works in the project. A migration to a new framework and a redesign on how the chatbot looks. Now let's move on to what are some major backend updates we did. And the next slide. So these are the major backend updates. First, let's talk about the pictures in this slide. The top picture contains how our old database was, and the bottom picture is how the new database looks like. The old database stored information with one keyword, along with a list of terms, which it extracted from the current web page on the second column. And the third column is the URL or web page where all the information came from. It's actually very redundant because for each keyword, it saved one line in a term. As you can see here, under term, we have name, and the first keyword is name. And then under the fifth line, we have introduction, and the second keyword is introduction, and so on. So of course, this contained a lot of unnecessary information. What we changed was we now save the URL and then save the list of keywords and categorize it and also give it a subcategory. This allows us to use a new classifier model where we could first search for the category instead of searching for each term and each URL where the keyword would be. So we would find the best matching category and match it with the category we found as the question. So if there's a staff question or finding a professor, it would match to the category of staff. Now, we have the removal of Amazon Lex. Amazon Lex is Amazon's chatbot, which the previous team used as their first step in the chatbot. The question would be sent to Amazon Lex to find an answer. And if it couldn't understand the question or find an answer, it would pass it on to the chatbot they created. We removed Amazon Lex because there were many questions Lex could not understand because the user is asking a question specific to the university. It would usually pass the question onto the Pineapple chatbot anyways. So we decided removing Amazon Lex would be the best option because it removes a whole method where we don't have to work on anymore. It also removes a paid third-party program. Now, the update to the Spacey model is what allowed us to remove Amazon Lex. We created new models to identify more entities where models are a set of assumptions where like a list of items is categorized, like keywords such as a name of a person would be categorized as staff. And we trade them with large sets of data to solidify this. So now we can categorize even more entities than before. One challenge we're still working on though is foreign names. Currently, we did not have enough data to train the models with enough foreign names to learn this in time. So usually whole parts of a name or a part of a name or a whole name would be skipped over. But with more data given to it, this problem should be fixed. And now I will pass it on to Yiling to talk about web scraping and database performance.
Okay. Hi. Now I'm going to talk about some improvements in our database and web crawler. As Kuong said, the first thing we did is redesign the database structure because the previous one we had contained many repeating data, and it took very long time for us to extract the information we need. Next slide. Yeah, here. So when we first test the chatbot, we start to analyze how the code works. We noticed that there are some strange behaviors from the web crawler where a lot of links have the same data set. We try to navigate to these links to see if it's the crawler's problem or something else. And then we found out that most of them are just dead links and the pages exist no more. So we send a HTTP request to these pages to see if it returns anything. And if it returns error code, we know it's that link so that we can just skip them. This will help reduce our database by a few hundred rows. Second, the last year student only include few HTML tags in web crawler. And this time we include more detailed data set to generate a valid and accurate solution. Third one, for the prioritizations, we will use this to identify the best match link to user. What it means is for certain HTML tags, for example, italic and strong tags, we will multiply the words within the tag about 5 to 10 times. The issues if certain pages, for example, in financial aid page, if it contains the word finance 100 times, then the word finance carry more weight than it doesn't in other pages. So that when user asks a question related to finance, this page will have more chance to be correct for the user need. And last, for some pages that have many repeating and redundant data, for example, words like you, me, yours, this, we will remove them all. We can eliminate 100,000 rows or more data by doing this in order to reduce the size of our database. Next slide. As you can see, when we first test our chatbot, it took more than 46 seconds to generate the answer. This is too slow and definitely not acceptable by any user. And as you see right now, it only takes less than 1 second, which is like a great improvement. Now I'm going to pass to next one.
Can you guys hear me?
Yeah.
Okay. So up until recently, Spacey was solely responsible for retrieving an answer for a user question. But before we get into how Spacey does that, we need to understand what Spacey is. So what is Spacey? Spacey is a free open source library for natural language processing in Python. Natural language processing, NLP for short, and NLP is just a branch of AI that concerns itself with the interactions between computers and natural human language. And NLP is important because NLP is used in our everyday lives, such as Googling for information or spell checking a message before it's sent. But what does this mean for the chatbot? Now, there are two ways to go about implementing NLP. We could use syntactic analysis or semantic analysis, or both. We focus on semantic analysis using name entity recognition, NURD for short, and NURD allows us to determine parts of text that can be identified and labeled into a group. For example, next slide. In the question, is Bob currently presenting during the Zoom meeting? We can take the name Bob and categorize it as a person, human, student, presenter, or anything we want. So essentially, NURD allows us to select custom labels, slap labels to relevant words, and use those labels to train models and recognize these labels to best fit our needs. So if we look at the ideal example, what is Krebs email, where a model is trained to recognize Krebs as a person and the word email as an intent. We can extract information from the database using the label person as a target and the intent for retrieving data belonging to the target. This works fairly well, but what happens when there is no clear label in the question? So if we look at the modified question on the realistic examples, what is Mike Krebs' email? The model will either recognize the full name, the first name, or the last name exclusively, or both the first and last name individually. This lowers the accuracy of our answers, since having more words increases the query results in our database. These multi-worded labels tend to pertain to general questions. And in reality, in most cases, the questions asked tend to be general questions. So to address this problem, we decided to reduce some of Spacey's responsibility in retrieving answers and adopted the Bayesian model to help increase accuracy for generic questions. And I'll let Enrique explain what that is.
Okay, so as Julio mentioned in his last example, when we began testing a broader range of questions that don't necessarily have one-word answers, like for the question, what is Mike's Krebs email? An answer to that will most likely be mike.krebs@calstatela.edu, right? But for the question, how do I apply for financial aid? The answer someone wants is like a step-by-step list of directions. And so we decided to approach this by using a different statistical model called the BEIJING model. For us, that meant that the user's question becomes, well, actually, the BEIJING model is a statistical model which compares the similarity of an input across different sets of data. So what that meant for us is that the user's question becomes the intent. And for the data sets, we derived a dynamic way to categorize each page. And with that, we now have different sets. We have different data sets. Now, the only thing we had to do was filter common words like how, do, I, or for, and filter the question to have only the keywords, something like you could see here. We then count the number of times these keywords appear within each data set and find the set with the most matching, with the most matches. The question is then categorized as financial aid in this example. And then any pages that contain the same category when we do our scoring algorithm get a accuracy boost in the process. And so pages with financial aid, for example, might have a higher chance of being the answer, but that doesn't necessarily mean that pages without the this category will are impossible to get. Because sometimes, even though it might be, as you know, machine learning is not perfect, there's a slight chance that it could be wrong. And so this is the way how we kind of elevate that. And then at the end, we give, instead of giving a direct answer to the user, we give them a link to where they find this information. So for example, how to apply financial aid, will send them a link to the page where it contains this information. And the next thing is our migration to Django. One of the things Kuong forgot to mention was that our project was handed down to us from last year, and there was a lot of work. There's a lot of work that needed to be done to it. Although the team did a great job in designing the systems architecture by even creating their own full stack application when we got it, the problem was that there was no documentation on how they use it or how they built it. And it even took us a few weeks to even get the software to operate. And so instead of kind of stressing ourselves out and reinventing the wheel, because as computer scientists, we generally want to reuse what it is that we have already, we decided to move over to Django. Django is a full stack Python framework that is it has a lot of documentation that's professionally written by the people who created this. It has a Python backend, which for us was a plus because we needed Python since our there's a lot of machine learning libraries that depend on Python. It's also very easy and to use, and it was very easy to write and migrate over. And as well as, since there's a large community for it, any troubleshooting issues that we might have had, we could always search them up and find forums with people who had similar issues. So moving into Django was a great decision that we did. And the next thing that we also did was redesign the front end. Since the last year's team focused a lot on how designing the systems architecture, not much emphasis was put into their front end design. As you see here, this is what the chatbot looked when we got it at the beginning of the year. There's not much to it, and honestly, it's a kind of something that we don't want to see on a website. And so we took the liberty of improving this to make it look something like this. This is our new front end, and how it looks. It's a lot simpler, very clean, and very easy to use, right? There's only a few buttons. There's directions to the left, and your questions and answers will be answered to your right. The next thing we did was speech to text dictation. Nowadays, almost any website that allows you to input text lets you input text through speech, whether that be through a third party from your phone, if you happen to be using that, or if you have software to do that, or if the website itself has the feature itself. Speech to text is very common now. And so just like you would see it in any other website, it's as simple as a click of a button, you talk to it, and the speech gets interpreted and it gets delivered to the software. And next, I'll hand it over to Jose to talk about mobile responsiveness and accessibility.
Hello, and in today's day and age, more and more people are getting access to a mobile device. And because of that trend, many companies are adapting their domains to be more mobile friendly. Our chatbot is also following suit and made our website to be more mobile friendly for our day-to-day users. As seen before, the mobile view looks more simplistic and is easier to use and follow. We adapted to be more simplistic since mobile users want answers quick and easily, so they don't really care how it looks as much. And since it's mobile, there's a touch. Go back. And since it's mobile, there's a touch screen, meaning to use the mobile interface is really easy. It's literally a touch of a button. And since, as Enrique stated, we have a text-to-speech button, it's as easy as just clicking with your finger or clicking the text box. Next. To add on to making better changes to our website, besides making it more mobile friendly, is also making the website more accessible. Making the website more accessible is important because we want everyone to be able to use it equally. So anyone who has a disability or of either eyes or age or any disabilities that might prevent them from fully viewing our website should be more easily to follow now if we follow more accessibility. Plus, it's easy on the eyes once corrections are done. And many companies are also following the web context accessibility guidelines because of this reason. And we will now go on to present the demo.
Okay, so now let's go for the demo. So what we will be doing is a live demo of the software that we can see here. So we'll start from fresh. And so we'll start simple by asking it one of the questions that was on the slides. So we'll ask it, how do I apply for financial aid? It's calculating the results, as you can see here live. It gets a clear score of it. The first ranking page will be delivered to the user, as seen here. Let's try something a little bit more harder. What, like finding somebody's email. So let's find Dr. Axis's email. So what is Dr. Axis's email? And there you go, we get his email instead of a link. So something that has more of a direct single answer, like an email or a phone or an office number might be grabbed from them and be delivered to the user directly. What about, I want to know what Dr. Zilong's page, I want to see what his work is. So let's try to find his page. And there you go. Like that, I could find his page and I could see what he has done. But, you know, these questions are kind of, you could say, perfect. And some people who are very due to this stuff, or very used to using the internet, don't necessarily speak in full sentences. So they usually just include what it is they want and what it is and who is it for. For example, just literally the entity and the intent. So they would write something like Dr. Zilong's page. And we're given the page. What about if you want to know the GE requirements for computer engineering? Again, students don't usually write their questions in full sentences. So we'll write an incomplete sentence and see if the chatbot can interpret that. And as you can see there, we've got a question. So these are some of the questions that we tried. I'm willing to try, have somebody from the audience maybe ask me a question. Maybe I could try it and see if it works. But do keep in mind that we do have a limited data set where some broad questions could be answered. For example, questions about financial aid or about admissions or about anything about ECST. We have that in our data set at the moment. If anyone would like to ask, have me try a question. No? Okay.
No, wait. They
chat.
send a chat. Yeah.
Oh. Let me pull that up. Chat. Where is the ECST makerspace located? Okay, let's try that. Let's see what this brings. Well, as you can see, we got the wrong answer. But you put what? Oh, where? Where is the ECST makerspace located? Same answer. But there's, like I said, we have a limited data space. This might not be included in our database. But as you can see, for some of the questions we did ask and some of the ways students might ask it, there is a possibility of getting the answer that we need. Going back to our presentation.
There's another question, I think. ECST Senior Design Expo.
Let's try that. Let's try that, ECST. Oh. Again, looks like this is the wrong answer. But you see the results here live. Moving on. Is there any questions that someone in the audience might have for us?
Any questions?
Okay, so I have a question. So for the speech to text, what software do you use to implement?
We used an open source Google speech platform that we used. Actually, we have not tried that. Let me actually demo that. Let's see if it works. My mic is being used by this, so let's see if it picks it up with me using it. So let me ask it. Let's see. How do I apply for housing? And there you go. As you can see, it works too. Okay.
Yay, it works. Yes, I think that this is normal because I think for the computer to be intelligently understanding the question and give the answer, it doesn't give the right answer all the time. So there's a probability on that. So I think there's still room for us to further improve it. But so far the work is good.
Okay.
Any other questions?
Let's try one more time. Teammates are giving me questions. See if this will work. Expo. Nope.
So can we see that from the ranking list? Can we see the results there? Or no?
I don't see it.
Okay.
But actually, I should explain.
Maybe it goes to a different category, and then we didn't find the answer. Maybe
Yeah, for this question, the category was labeled as admissions.
Oh, okay. Then it
So,
doesn't find it. Yeah.
right. So let me actually go through quickly what the process is. So when a user asks questions, we could first kind of check. We first check whether we got it and print that out. And then we check for any intents and entities. For this question, we didn't find anything. And so we fall back to the BEIJING model part where we use that. And as what we do next is filter out the words that we don't need. For this question, the only words we need are apply and housing. The question is then categorized, in this case, housing. We then query our database using these two keywords and make a union of them, and then start scoring the results. And then sort them from highest to lowest and deliver the highest scoring one to the user, as you can see there. If we go a little bit higher and we go to where we asked an email, here it is. We do the same thing. We see if we got the user's email and we print that out. We check if there's an intent and an entity. For this question, the intent is get an email. And for the entity, we know we got a person entity, in this case, it being ACUS. We then call the method that follows this, query the database, and do the same thing and start scoring and see which links we can get. We then go through the top scoring URLs, keywords. So this would mean, for example, all the text that is found in this page. And then we start looking for their email. In this case, we find his email, which is right here. And we deliver that to the user. And that's about it. That's how our software works. If you ever have any questions, this is how you can reach us. And that's it, unless there's more questions.
Okay, good. Thank you guys for the great work. And also thank our liaison for supporting the project and also working with the students. I think we achieved a better version of the chatbot in this year. And then we also learned a lot in this project. So thank you all. And this is the chatbot presentation.
Thank you.
Thank you.
Great job, guys.
Thank you.
Thank you.
Okay, good.
Done.
Yeah, we're done.
Done.
Okay,
And that was
so
40
maybe we
minutes.
can end the meeting, and then we still have a few deliverables to work on after
Right.
the expo. So which is the report.
Just
and
the
also
report, right?
Yeah. So we'll continue working on that during maybe through the email, or we will also have our weekly meeting next week to discuss the final deliverables. Okay.
Okay. Sounds good.
Yeah.
Sounds
Thank you.
good.
Thank you, guys.
Thank you.
Bye bye.
Bye.
Stay safe.
Bye.
All right. Bye.